Respected participants, we are having with us Dr. Rudra Pratap Singh Chauhan, the speaker for the second session for the day. All the participants are requested, if they are having any query, they have to ask the question in the chat box. Otherwise, or you can ask directly from the sun. What they have to do, they have to raise their hand. I will unmute from here, and they have to unmute from their side also, so that they can talk to the directly to the sir in the question answer session.
Sir, shall we start?
Sure, sir, sure. No issue, no problem. Please.
Okay, respected participants, we are going to start the second session for the day. We are pleased to inform you that we are having the session to be speak by Dr. Rudra Pratap Singh Chauhan. His talk will be on the implementation of sensor data with IoT and machine learning algorithm. Chauhan sir, I am handing over to you for the session.
Thank you, sir. Thanks for giving me an opportunity to be the speaker in this wonderful webinar on this topic of the deep learning, the artificial neural network and deep learning for real-time applications. So my topic is that the implementation, the real-time implementation of the sensor data with the machine learning algorithm. So I welcome all the participants, and I'm thankful to the management for giving me an opportunity to share my experience in this the field of the machine learning and the IoT. So let me give the permission so that I can share my PPTs. This PPT is visible to you?
No, sir.
Hello? No. Okay. Let me check. Is it visible?
Yeah, now it is visible.
So today I'm going to present this implementation of sensor data with IoT and machine learning algorithm. So we'll start first. What is the Internet of Things? The Internet of Things or IoT refers to systems of interrelated, interconnected objects that are able to collect and transfer data over a wireless network without human intervention. The Internet of Things generate massive volume of data from millions of devices. Means we can take the data from the various sensors. We have humidity sensor, we have the temperature sensor, we have that heartbeat, the pulse rate sensor. So we have different kinds of sensor from where we get the data, and with the help of different IoT device, that is ESP8266, ESP32, Raspberry Pi, and we use that I am using ThingSpeak Cloud for the IoT application. So we'll let you know what is the ThingSpeak Cloud and how we create a channel for accessing the data from the sensor. And once the data is obtained from these device, we can download the various kinds of data in the form of CSV files. Once we get the CSV file, then we can able to use those CSV file in a machine learning algorithm to build a model. So this is my area where I am here to present this. So what is machine learning? Machine learning is powered by data and generate insight from it. Means all machine learning is all about data. Means how well your data, how clear your data, how you pure your data, your model will predict efficiently, or we can say that the accuracy of the model is good. So machine learning uses past behavior to identify patterns and build model that helps predict future behavior and events. IoT and machine learning delivers insights otherwise hidden in data for rapid automated responses and improved decision making. And machine learning for IoT can be used to project future trends, detect anomalies, and augmented intelligence by ingesting image, video, and audio. So here I am requesting the participants, if you want some hands-on experience, so I request all the participants to please be with me with laptop and internet connectivity. So later on this session, I will demonstrate one project based on the heart disease prediction with the help of logistic regression. So I request all the participants, so please be with me with laptop and internet connectivity, so that it will be great for them to learn the hands-on machine learning, how to build the model. And why use machine learning for IoT? Machine learning can help demystify the hidden pattern in IoT data by analyzing massive volume of data using sophisticated algorithms. So we have a lot of algorithm in machine learning, and we can use those algorithms. We have different kinds of machine learning. We have supervised learning, unsupervised learning, and the reinforcement learning. So we have different types of algorithm based on those type of the learning. And machine learning inference can supplement or replace manual processes with automated system using statistically derived action in critical processes. So with the help of machine learning, the automation is possible. The life of the human beings is more easy, because the system gets automated. They can do new things, they can think themselves. Like, this is the main advantage of building a machine learning model, or we can say that to create an intelligent machine. Companies are utilizing nowadays machine learning for IoT to perform predictive capabilities on a wide variety of use cases that enables the business to gain new insights and advanced automation capabilities. So nowadays it is very much in news that the Tesla company will try to build an automated car that is called the driverless car. So this is the main example of the artificial intelligence. Means we are creating the machine to behave as an intelligence, or we can say that the machine or the device can able to think, or they can able to do new things. So this is nothing but the artificial intelligence or the machine learning. With machine learning for IoT, you can ingest and transform data into a consistent format, build a machine learning model, deploy this machine learning model on cloud, edge, and device. For example, using machine learning, a company can automate quality inspection and defect tracking on its assembly line, track activity of assets in the field, and forecast consumption and demand patterns. Some of the benefits of machine learning inference for IoT. Machine learning is a key component of soft edges Cumulocity IoT low-code self-service IoT platform. The Cumulocity IoT is an independent device and application management, that is IoT platform. It connects and manages your device and assets efficiently and can control them remotely. So this is the key advantage of the Cumulocity IoT device. The platform comes ready to go with the tools you need for fast results. Device connectivity and management application enables an integration as well as streaming, analytics, machine learning, and machine learning model deployment. The platform is available on the cloud, on premises, and or at the edge. So uniquely with Cumulocity IoT, the standalone edge-only solution are also supported. So this is the key area where the most of the companies are thinking. They are trying to build this cumulative IoT-based system, which interconnect and manage the device and asset efficiently and can control them from them remotely. So the kind of automation can be provided with the Cumulocity IoT. Then next is this is the ThinkSpeak cloud. So I am working on this ThinkSpeak cloud for the IoT related application. So it is nothing but it is basically MathWork has invented the ThinkSpeak, an IoT based data analysis platform that service enables the developers to combine, process, analyze, and visualize the smaller or big data in the cloud environment. It also supports the data analysis on live streaming data with the help of API, that is application program interface, for direct connection to the cloud system. ThinkSpeak specifically uses for analytics and visualization of data using MATLAB code, and it helps to perform online analysis using MATLAB. ThinkSpeak system essentially used for IoT device. We have different kind of IoT device. We can use Raspberry Pi, we can use ESP32, ESP8266. So these are nothing but the Wi-Fi module, which can be easily available in a very low cost, that is 300 to 500 rupees, or the Raspberry Pi is about 3 to 4,000 rupees. This is the nominal cost of the IoT device, which can be very much used for the IoT related application for the system generated data analytics with cloud support system. So this is the overall picture. This is the home environment, and we need to deploy a sensors which will collect the data with the help of this ESP8266, which is nothing but the Wi-Fi model and the Arduino. And we have the internet, the things with cloud, through which we can able to gather this data, and from where we can able to download the data in the form of CSV file. And it is, once the data is obtained, so we can perform, we can use the machine learning, or we can use this data to train a machine learning model for the model building. So this is the kind of the workflow which can be used to gather the data from the IoT device with the help of sensors. The IoT device is able to sense the data with the various kind of sensor. So I am here, for example, I'm using the ST11 sensor for the measurement of the temperature and humidity. We can also use the heartbeat sensors, which can sense the pulse rate, and the data can be fed to the cloud server, that is ThingSpeak Cloud. And from that, we can able to generate the CSV file, that is the comma separated value, the files in the form of comma separated value, and we can use this data for the machine learning deployment. So we can also build, or we can also control the various appliances with the help of mobile device, with the help of Blink app. So this is another example where the IoT can be useful. We can use this the mobile app, that is Blink app. With the help of that, we can able to control the, or we can provide the home automation. We can control various devices like fan, fridge, TV, like that, with the help of this mobile app. So this is another area where the application of IoT is suitable. And here the various the devices, IoT device, we can use Raspberry Pi, Arduino, then the ThingSpeak Cloud. Then another is we can use Python also for the various devices, ESP32, ESP8266, Raspberry Pi, we use Python. And the Microsoft Azure, this is another the cloud. Then we can use the Power BI, this is nowadays which is very much common. So these are the various devices which can be used for the IoT application, and we can use Python for the machine learning model. We can use the Python for the machine learning. We can also use the MATLAB also for machine learning, but as per the requirement, nowadays this Python is very much used for the machine learning model. So I'm preferring that Python over MATLAB, because it is very easy language and the syntax is very easy as compared to the MATLAB. So the ESP32, that is the Wi-Fi model, and ESP, that is Node MCU, ESP8266 is another Wi-Fi model which can be used for the IoT related application. And this is the result which can be displayed. This is the potentiometer value and the date. With respect to this, we can able to create the channel. We can able to that measure the we can able to get the graph with the help of these values. So this can be possible with the ThingSpeak Cloud. So this application is possible with the ThingSpeak Cloud, through which we can able to plot the graph between the two datas. Then in this ThingSpeak, you need to create your account in this ThingSpeak if you want to do IoT related project. So this is the ThingSpeak. You need to first create your account, then go for My Channel. You need to create new channel. So by default, this is free. You can able to create 3 channel at a time, not more than that. If you want to create more channel, then you can pay for it for more channels. So up to 3 channel it is free. So for creating a channel, you go for this. First, you need to make your account in the ThingSpeak Cloud, and then go to the channel, then My Channel, then this is the new channel. So this way we can able to create a new channel. So here you need to give the name, that is IoT related project, description, that is the heart rate monitoring system, and field label 1, you need to mention the parameters. One parameters, the pulse rate, another parameter, that is the time. So we can give this. So this is the way through which we can able to create the channel. So we need to fill some information on this the rectangle box, so we can able to create this channel. So this way we can able to create the channel in the ThingSpeak Cloud. Now the API key. So this is the two important key in this ThingSpeak. We have the write API key and read API key. So this write API key, use this key to write data to a channel. If you feel your key has been compromised, click generate new write API key. So if you want to generate new, so you can able to generate new write API key for that. And if you want to read API, that is the read API, if you want to read the data from the sensor, so we need this read API key. So you use this key to allow other people to view your private channel, feed and chart. So click generate new. So we can able to generate the new key also. So this is the API key which is used in your program, embedded C program. So we'll need to create a channel. We need this API to read and write the data in the ThingSpeak cloud. And this is the diagram through which we can able to that understand how the data can be sensed, and it will send to the ThingSpeak IoT cloud, and then again the data can be read. We can sense the data, we can read the data, and we can write on the LCD serial monitor. So we can send the data into LCD monitor for displaying purpose. So this is the kind of approach we can use in the IoT related project. And these are the various kind of result which can be obtained. We can also able to obtain the histogram of facial variation, and we have this temperature and the humidity correlation also in temperature, humidity, YY plot. So there's a various kind of plot can be obtained in this ThingSpeak. So we can able to analyze our the data with the help of these plots. Now let's talk about the artificial intelligence, machine learning and deep learning. So what is the basic difference between the artificial intelligence, machine learning and the deep learning? So it can be explained with the help of this diagram. So if we see this diagram, so it is pretty clear that the artificial intelligence nothing but is a broader sense. And if we talk about the machine learning, so machine learning is a subset of artificial intelligence, and the deep learning is further a subset of machine learning. So there is a clear picture. If I'm talking about the artificial intelligence, so it is a broader sense, means in artificial intelligence we are making the device as an intelligence device. And what is machine learning? Machine learning is all about data. Means the machine learning model required data. This data can be a labeled data or unlabeled data in case of supervised or unsupervised learning respectively. So according to those data, the model can be trained, and after training the model, we can test the model for the better accuracy. So this is nothing but the machine learning. And in deep learning, in some area, the machine learning will not give the better accuracy in case of image and video processing, because we need to handle large volume of data. So in this case, we need deep learning. We go for deep learning, and in deep learning, we use the various neural network, that is artificial neural network, the convolution neural network, for the data processing. So this is nothing but the basic difference between the artificial intelligence, machine learning and deep learning. Now let's talk about the artificial intelligence. So what is artificial intelligence? Artificial intelligence is a branch of computer science that is concerned with building smart and intelligent machines. So I repeat the definition. Artificial intelligence is a branch of computer science that is concerned with building smart and intelligent machine. So this can be explained with the help of these two examples. So I'm taking the example of non-intelligent machine, that is nothing but the wristwatch and the bike, which can be used normal day-to-day life. So these device can not think themselves, or not able to perform new things. They can use for repeated tasks. Means we can use this wristwatch for just finding the time, what is the actual time, and this bike is used to travel from one distance to another. So this is nothing but the device are meant for the particular purpose. Means they can able to perform repeated tasks. But if I'm talking about the intelligent machine, and here I'm giving the example of Tesla car, which is nothing but the example of intelligent machine, which is also called the autonomous car, because it is the car which is able to think itself. It can take decision by themselves, and it does not require any kind of input from the driver. So it is nothing but the example of driverless car. So nowadays it is very much in news that Tesla is going to launch a driverless car which can able to think itself, which cannot take any kind of input from the driver, or we cannot require any driver to drive this car. So this is the example of intelligent machine. So how the artificial intelligence comes into picture to make a car as an intelligence machine or intelligence car, or we can say that autonomous car. The another example is nothing but the Google Assistants. Nowadays we can feed any kind of text to this Google Assistants, and it acts as a human being, normal human being, rather than a kind of algorithm or the computer algorithm which is used to run a certain kind of algorithm. So it is nothing but the example of the intelligence machine, or we can say that we can use artificial intelligence for the Google Assistant. So these are the common example of the intelligence machine. So what is artificial intelligence? The artificial intelligence is nothing but by making the device intelligence, so that the device can able to take the decision by itself, and they can able to perform new things. So this is nothing but the artificial intelligence, and making the device as intelligence rather than non-intelligent machine. Next, talk about the machine learning. So what is machine learning? Machine learning is a technique to implement artificial intelligence that can learn from the data by themselves without being explicitly programmed. So here in machine learning, the main thing is that we need a data, and with the help of this data, we can able to train our machine learning model. So we can split the data in training data and testing data. And with the help of trained data, suppose we have the 100% data. So out of 100% data, and the 80% data or 70% data is used for training purpose, and 20 or 30% data is used for the testing purpose. So the training data is used to train the model, and test data is used to test the model or predict the output. So this is the main thing in machine learning. So here I'm giving the example. We have two images, that is Iron Man and the Captain America. So here we need to build a machine learning model. So the machine learning model is able to predict whether the image belongs to Iron Man or the Captain America. So in this case, we feed numerous amount of image of the Iron Man and the Captain America, and the machine learning model will identify the hidden pattern or the characteristics of these images, and on the basis of these characteristics and pattern, it can identify that the particular image belongs to the Iron Man, or this image belongs to the Captain America. So when we pass any new image in the form of Iron Man or Captain America, so as the machine learning model is already trained with these numerous image of Iron Man and Captain America, and it is able to find the characteristics and pattern of those images, so that the machine learning model can able to predict clearly that the image belongs to Iron Man or the Captain America. So this is the requirement in the machine learning. So we require a lot of data, and that data can be split it into training data and test data. The training data is used to train the model, and test data is used for testing the model. So this is nothing but machine learning. So here the machine learning, with the help of this, we can feed the lot of image. That another example is dog image, cat image, and the horse image. And the machine learning will try to learn with the help of the characteristics and the pattern of those kind of image. And according to this characteristics and the pattern, the machine learning model is able to predict this image belongs to the dog image, cat image, or horse image. But how human learn? We learn through the example. A long ear and black nose, it means that it is dog, and we need some different kinds of diagram, and according to that, according to the comparison we made, we can able to predict that this image belongs to the dog image or the cat image. So this is nothing but the human learning, but this is nothing but the machine learning. The model will learn from the data, from the past data. So this is nothing but the difference between the human learning and the machine learning. Next, talk about the deep learning. So deep learning is a subfield of machine learning that uses artificial neural network to learn from the data. So here in deep learning, the artificial neural network is same as that the neuron of the human brain. So here the neuron of the human brains are interconnected with each other, and it will pass the information from one neuron to another neuron. Similarly, in artificial neural network, we have the different kinds of layer, that is input layer, hidden layer 1, hidden layer 2, and the output layer. The input layer, the information is passed from input layer to hidden layer 1 and hidden layer 2, and from hidden layer 2 to output layer. So this is nothing but the artificial neural network And in case of deep learning, we use the artificial neural network to learn from the data. So this is nothing but the deep learning, and deep learning is mainly used for the image processing and the video processing, because we need to handle large volume of data. And for this large volume of data, the machine learning model will not give the better accuracy. Now let's talk about the types of machine learning. So what is machine learning? So machine learning is mainly classified into the three types, that is supervised machine learning, unsupervised machine learning, and the reinforcement learning. So let's talk about this different kinds of machine learning one by one. So this machine learning, as the definition is already explained in my previous slide, so machine learning is a technique to implement artificial intelligence that can learn from the data by themselves without being explicitly programmed. So here we have a different kind of image, that is dog image and the cat image, and we can pass this image to the machine learning model. So the model can learn from the characteristics and pattern of those kind of image, and it can able to predict the output, whether this image belongs to the dog image or the cat image. Now let's talk about the type of machine learning. So again, we have supervised learning, unsupervised learning, and reinforcement learning. So what is supervised learning? In case of supervised learning, the machine learning algorithm learn from labeled data. So here it is very, very important point. If I'm talking about supervised learning, so here in case of supervised learning, we are using the labeled data. So what is the significance of this labeled data? So here I'm taking the example of apple image and the mango image, and here we can here I am labeling this image as the apple image or the mango image. So this is called the labeling of image, or this is called the labeled data. So in case of supervised learning, a supervisor will supervise the model in terms of labeled data. So what is the meaning of supervised learning? In case of supervised learning, a supervisor will supervise the model with respect to the labeled data. And once this labeled data is fed to the machine learning model, the model will again try to find the features of this image, the color of that image, or the pattern or the shape of that image. And according to that, when we feed unknown image as a test image, so the model will predict correctly that this image belongs to the apple image. So this is nothing but the supervised learning. Next is unsupervised learning. So in case of unsupervised learning, the machine learning algorithm learn from unlabeled data. So this is the basic difference between the supervised learning and unsupervised learning. In case of supervised learning, we are feeding the labeled data, but in case of unsupervised learning, the model is use unlabeled data. So again, I'm using the same image, the apple image and mango image, but this time the image is not labeled, it is unlabeled data. So once this image is fed, or once this image is input to this ML model, that is machine learning model, so here the model will form a two group, that group 1 and group 2. Group 1 belongs to the apple image and group 2 belongs to the mangoes image. So here, according to the features, the characteristics or the color or the shape, the model will form a two group, that is group 1 which belongs to the apple image and the group 2 which belongs to the mango image. So this is nothing but unsupervised learning, where we need to give input as a unlabeled data. So here there is no supervisor, we are not supervising the model in terms of labeled data. Here we are feeding the unlabeled data. So the machine learning model by its own try to find the two group, that is group 1 and group 2, try to build a two group 1, group 2, and the group 1 belongs to one image which is apple image, and group 2 belongs to other image, that is mango image. So this is the unsupervised learning. The third is nothing but the reinforcement learning. So reinforcement learning is an area of machine learning concerned with how intelligent agent take action in an environment to maximize its reward. So this is nothing but a reinforcement learning. It is sometimes some kind different with the supervised and unsupervised learning, because it is the area of machine learning which concerned with how we need to build an intelligent agent which will take an action in an environment in order to maximize this reward. So if I'm talking about the reinforcement learning, so we have the four major aspects of this reinforcement learning. We have the environment, we have the agent, we have action and reward. So here we need to build a model that is nothing but the computer. We need to train the computer to play a chess game. So here I'm taking the example, we need a computer which is nothing but an intelligent agent. This computer acts as an intelligent agent, and this the intelligent agent is trained to play a chess game, what is the ultimate reward? Winning the chess game is nothing but the ultimate reward. So here the chessboard is nothing but the environment, and the machine is nothing but the intelligent machine. So here, what is the requirement? The agent will try to make some move, and the if it make a move in the direction to win the game, so it is called the positive move, and it will give the positive reward. And if the action of this agent towards losing the game, so this is nothing but the negative, and this is nothing but the negative reward. So the agent will itself will learn if the agent will move in the positive direction, it will maximize the reward. It will the ultimate reward, ultimate goal is that to winning the game. And if any kind of bad move, it means that there is a chance of losing the game. So this is nothing but the reinforcement learning. So reinforcement learning is mainly used in the area of the game. We can build the various application, that is game playing, and we can use the drone in the automated drones. We can use this reinforcement learning. So this is the area where we use reinforcement learning. Then let's talk about the supervised and the types of supervised learning. So in case of supervised learning, already explained, we need a labeled data. The supervisor will feed the input in the form of labeled data. So this is nothing but the supervised learning, and on the basis of that labeled data, the model will predict the unknown image correctly. So this is the supervised learning. Now, type of supervised learning. So supervised learning is mainly classified into two types, that is the classification and the regression problem. So mostly the supervised learning is classified into these two types of learning, that is classification problem and the regression. What is classification? Classification is about predicting a class or discrete value. So in case of classification, the value is always discrete between one or either 1 or 0, that is male or female, true or false. There is no any value in between 1 or 0. So it is nothing but a kind of discrete value, whether it is 1 or 0, means predicting the patient, whether the patient is heart patient or not. So if the patient is heart patient, the value is 1. If the patient is not a heart patient, the value is 0. So this is nothing but the discrete value. So this is nothing but the classification problem. Next is the regression problem. So what is regression? Regression is about predicting a quantity or continuous value. So the example is salary, the salary of a person with respect to its experience, age of a person, the price of a product. So these are nothing but the example of regression, where we need a continuous value, means with respect to one variable, we need a continuous value of the another value. So this is nothing but the regression problem. So this is the classification of supervised learning. Let's understand the classification in more detail. So what is classification? This is the types of supervised learning. So in case of classification, again, I'm taking the two different image, that is dog image and the cat image. And this dog image and the cat image, the numerous dog image and cat images is feeded or inputted to the machine learning model. The model is trained in terms of the label data because it is supervised learning. So we are giving the input in terms of the label data, label image, that is dog image and the cat image, and the model will train accordingly with the help of trained data. And after training, the model can predict, when we feed a test data, the model will predict correctly whether this image belongs to dog image or the cat image. The regression is nothing but, I'm taking the example of temperature with respect to the rainfall in centimeters. So we feed a numerous amount of the data of the temperature, and we need to note down or measure the rainfall in centimeter, means a particular temperature, how much rainfall is in centimeter. So this kind of data is input to the machine learning model in case of regression, because it is a continuous value, because with respect to one parameter, we need to note the another parameter. So this is nothing but the continuous value. So once the model is trained with this continuous value, with temperature and the respective rainfall in centimeter, and when we feed a new temperature to the model will predict correctly at this temperature that much amount of rainfall. So this is nothing but the regression problem. So these are the example of the classification, the regression in case of supervised learning. Now, the various algorithm which is used for the supervised learning classification. In case of classification, we use decision tree classification, we use random forest classification, we use k nearest neighbor classification. So these are the classification algorithm which is used for the classification problem. In case of regression, we use logistic regression, polynomial regression, and support vector machine. So I am discussing logic regression today in one of my project, that is hard disease prediction with Python, that is the hands-on. So I request all the participants be with me with laptop and internet connectivity. Now let's talk about the unsupervised learning and the types of unsupervised learning. So first is unsupervised learning. In unsupervised learning, the machine learning algorithm learn from unlabeled data. Excuse me. So here, unsupervised learning, we need to give input in terms of unlabeled data. So according to this image, the model will form two groups. The group one belongs to one image, and another group belongs to the second image. And types of unsupervised learning. So the unsupervised learning are mainly classified into two different kinds of problem, that is clustering and the association. What is clustering? Clustering is an unsupervised task which involves grouping the similar data points. So here we need to group the similar data points. Means if I'm taking the example of the apple image and the mango image, so the similar data point means the apple image having the similar data point. So those data point can be grouped in group 1, and the mangoes image data point will group to the group 2. So this way we can make a cluster in two group 1 and group 2. I'm talking about the association. So association is unsupervised task that is used to find important relationship between data points. So what is association? In case of association, we need to find out important relationship between the data points, means how the data, huge amount of data, are interrelated with each other. So this is nothing but the association. So I'm giving the example of clustering. So here the example is nothing but am I audible na? Hello? Hello? Am I audible? So
Yes, sir. Yes, sir. You are completely audible.
Yeah. So here I'm taking the example of this clustering algorithm of the unsupervised machine learning. So here the example is that nothing but the telephone company, and the task is given that how the telephone company is need to maximize its revenue. So here we have two different kind of group, that is this two groups are nothing but it is a kind of cluster, that is group 1. The group 1 will consist the person which is having the high internet uses and the low talk time, but in cluster 1 having the more talk time and the low internet uses. So the task is given to the machine learning model to maximize the revenue, means the kind of suggestion we will give so that the person can able to take both the benefit, means it is the person is able to take the use of the internet as well as the call duration also. So here this is the task which is given to the clustering machine learning algorithm. So here the machine learning model will make a two cluster, and the kind of suggestion it will give by the company to make some scheme or some things so that the person can take both the benefit, means the internet uses and the maximum call duration. So this is nothing but the problem which belongs to the clustering. Next is the association problem. So here the in case of association, so I'm taking the example of supermarket. So here there are three kind of customer, that is customer 1, customer 2, and customer 3. And the customer 1 will buy a product, certain product, that is bread, milk, fruits, and wheat. So these product can be bought by the customer 1 from the big market, and the customer 2 will buy that bread, milk, rice, and butter. So if I'm observing the product that the purchased by the customer 1 and customer 2, that is the common products are bread and milk. So we can easily predict if the customer 3 will purchase bread. So we can suggest customer 3 that the customer 3 will also, or we can predict that customer 3 will also purchase milk, because these are nothing but the previous data or the past data according to the customer 1 and customer 2, means the common thing is that the bread and milk is common. So when the person or the customer purchase bread, so it is surely purchase the milk also. So now when the customer 3 goes and buy bread, it is highly likely that he will also buy milk. So this is nothing but the association. Then unsupervised learning algorithm. So we have different kind of algorithm, that is K means clustering, hierarchical clustering, principal component analysis, a priori, and eclat. So these are the various kind of algorithm which is used for the unsupervised machine learning. So let's talk about the overview of Python library for data science. So we have the different kind of library for plotting the descriptive statistics, because these libraries are very much needed in case of the machine learning models. So we have the different kinds of Python library, that is NumPy, which is used for the numerical computation, that is numerical Python, then scientific Python, that is SciPy, and the Pandas and Scikit Learn. So we can use from the Sklearn, we can need to import various model for the machine learning algorithm. So all these libraries are installed in this Python package. So we need to import that. Then we have a visualization. If you want to visualize your data, we need matplotlib library and seaborn library for that. And what is Python library for data science? That's NumPy. NumPy is numerical Python. It introduces object for multi-dimensional array and matrices, as well as functions that allow to easily perform advanced mathematical and statistical operation on those objects. So we are using list also, but it is list and tuple in Python, but the using of NumPy is more faster, because we need to handle huge amount of data in machine learning. So we can use list tuple, but the processing time may increase. So by using this NumPy, the processing time will reduce. So that's why we use NumPy over the list and tuple. Then it provides vectorization of mathematical operations on array and matrices, which significantly improves the performance. We can also able to perform various mathematical operation with the help of numerical Python, and it can improve the performance of machine learning model. Then many other Python libraries are built on numerical Python. Then next is SciPy, that is scientific Python. This collection of algorithm for linear algebra, differential equations, numerical integration, optimization, statistics, and more. And part of that scientific Python stack, then built on NumPy. So these are the Python library for data science. Then the another useful library, that is Pandas for data frames. We use the Pandas library for the data frames. So it adds data structure and tool design to work with table like data, means we can convert CSV file in the data frame. So once the data is in the form of data frame, so we can add or delete the column, or we can able to manipulate the data according to our requirement. Then provides tool for data manipulation, reshaping, merging, sorting, slicing, aggregation is possible with the help of Pandas data frame. It allows handling and missing data, means we can able to observe the missing data, because we need the data which is pure data, otherwise the efficiency of the model will decrease. So this kind of the data the pre-processing of data can be possible with the help of this Pandas library. Then we have the Scikit Learn, the another library. So we need to import the various algorithm, that machine learning algorithm, that is classification, regression, clustering, model validation. So this all kinds of algorithm which we need to import from the Scikit Learn, that is Sklearn, that is built in NumPy and SciPy and matplotlib. So we have different algorithm which is required to import from the Sklearn library. Then the matplotlib, Python two-dimensional plotting library, which produces publication quality figures in a variety of hard copy format, a set of functionalities similar to those of MATLAB. Lines plot, we have different kinds of plots, that is line plot, scatter plot, bar chart, histogram, pie chart, etc. with the help of this matplotlib. So we need to import this library. Then relatively low level, some effort needed to create advanced visualization, means this matplot library is used mainly for the data visualization. So with the help of data visualization, we can understand the data. Once the data can be visualized in the form of graph or plot, so we can identify the relation of the data, and then we can able to deploy the machine learning model, or we can able to choose the machine learning model which is best suitable. In Python library for data science, that is the Seaborn library, that is based on matplotlib and provide high level interface for drawing attractive statistical graphics. So similar to the popular, that is ggplot, that is the geographic plot library, that is same in the R programming. So this is the very useful library for the machine learning, the Python library for machine learning. Then if you want to use this library, we need to import this library, means import numerical Python as NP. This NP is nothing but the alias of NumPy. Then the scientific Python, the SciPy as SP, import Pandas as PD, import Matplotlib as MPL or PLT, import C1 as SNS. So these are nothing but the kind of library we need in machine learning model. If you working on this Jupyter notebook, so you need to, if you want to run a particular cell, so we need to press Shift plus Enter, or also in Google Collab. So I am just taking this session in the hands-on on Google Collab. So if you want to run a particular cell, so we need to press Shift plus Enter together for running the individual cell. So this is nothing but the hard disease prediction. This is the project of the machine learning. Today I'm going to discuss this hard disease prediction with the machine learning model. So the workflow of this project. So here the hard data which can be gathered from the IoT device, from the sensors. So we need a pulse sensor over there, and the IoT device, that is Raspberry Pi ESP32 or ESP8266. So we can deploy our model and take the data. Once the data is gathered with the help of ThingSpeak Cloud, so we need to download this data in the form of CSV file, and from CSV file we need to convert into data frame with the help of Pandas data frame. So once the data is converted into data frame, then we need to pre-process the data, whether the data is required to pre-processing. What is pre-processing? Pre-processing nothing but data cleaning. So the important task, this step is very, very important in machine learning model, because how pure your data is, the model will give the maximum efficiency. So all about your data. So it all depends upon your data. If the data is pure, means the data will not have any missing value. So so it is we can say that this data is good data, and we can use this data for training the model, because we need to train the model with the help of this data. So here the next step is nothing but train, test, split. So as already explained, that once the data is pure, that pre-processed, so this data is split into two parts. There is part A is nothing but train data, and part B is nothing but test data. So I'm taking the 100% data. So 100% data out of 100%, we are using this 80% data as a part A for training purpose, and 20% data as part B for testing purpose. Once the data is split in training and test, then we use this trained data for logistic regression model, because I'm using logistic regression model for predicting the hard disease. So the logistic regression model is trained with the help of trained data. Once the model is trained, so here this trained logistic regression model. So once the model is trained with the help of trained data, means with the help of the data A, then we feed a new data, that is the data which is the test data, which is the part B data. So this data, new data, is nothing but the test data. So the data is the model is already trained with the help of trained data. So it will give the maximum efficiency, or it will predict the patient, whether the patient is healthy or heart defected. So this is the use of the test data. So this is the kind of workflow in case of the heart disease prediction with the help of logistic regression model. So here the train, test, split method. So data can be splitted into training data and test data. Then the training data is used for building the model and validate the model. Then the new data is fed in the form of the test data, and it is used for the prediction. Once the model is trained, then we can use this test data for the prediction the output. So historical data, then machine learning algorithm, then this is called the model training. That phase one is called the model training. So here the data is used, this trained data is used for predicting the training the model, and the new data is used for predicting the outcome. So this is the train, test, split. And let us talk about logistic regression. So the logistic regression is nothing but the logistic regression is nothing but a supervised learning model. and it is the classification model based for binary classification problem and use sigmoid function. So it use sigmoid function. So as already explained, in case of supervised learning, we are feeding the data in the form of labeled data. Means we are the data is input. The input data is nothing but it is a labeled data. So here the example is dog image and the cat image. So we have numerous or different dog image. These two are the dog image, different dog image and different cat image. So this is nothing but the labeled data, and this is nothing but the unlabeled data. So this is the significance of labeled data and unlabeled data. In case of labeled data, we are labeling the image, while in case of unlabeled data, we are not labeling the image. So here, since I am discussing the supervised learning model, so we are here I am using that the labeled data, and here as in case of the classification, so it will classify the image as in class A and class B. So whether this class A belongs to the dog image and class B belongs to the cat image. And this is the sigmoid curve. So here the mid value is 0.5, when the value which is greater than 0.5 means it is 1, and the value which is less than 0.5 which is 0. So this way, the according to this sigmoid curve, the model, this logistic regression will work, and the model will predict if the value is less than 0.5, so it is 0, and it belongs to class B, and if the value is greater than 0.5, so it belongs to class A. So this is the sigmoid function which is used in logistic regression. And here the this is the sigmoid plot. So here y cap is nothing but the probability that y is equals to 1, means predicting y is equals to 1, and y cap is equals to the probability of y is equals to 1 with respect to the input feature, which is x, and w is nothing but the weight. So this is the number of weight which is equal to the number of input features in a data set. So this is the sigmoid function which is given by y cap is equals to 1 upon 1 plus e to the power minus z, where z is nothing but z equals to w into x plus b, where x is nothing but the feature and w is the weight and b is nothing but the bias. So this is the logistic, this is the mathematical mathematics about the logistic regression. Advantage of logistic regression: it is easy to implement, perform well on data with linear relationship, less prone to overfitting for low dimensional data set. So it will perform overfitting for the low dimension data set, means we require huge amount of data for the better output. And disadvantage is high dimension data set cause overfitting, and difficult to capture complex relationship in a data set, sensitive to outliers, needs a larger data set. So we require larger data set for the better efficiency. Now the important the project, for that particular project we need to import the dependency first. So what is dependency? We need to import all the libraries, Python libraries for the machine learning model. So in this first step, we need to import the pandas as pd, numerical Python, that is numpy as np, that if you need to want 2D plot, so we need to import matplotlib library, that is import matplotlib.pyplot as plt, then import cborn as sns. Then this is the sklearn models, from where we need to import trend test split, means we need to split the data in training data and test data. So we need to import trend test split from the sklearn model selection. Then sklearn.linear model, we need to import logistic regression because we are using this logistic regression in this particular project. And if you want to find the accuracy score, so we need to import this accuracy score from the sklearn.matrix. So these are nothing but the dependencies which are required. So this is the first step in the machine learning model to import the dependency. Next is nothing but the data collection and processing. So we need to use the pandas data frame. So the CSV file is converted into a pandas data frame. So loading the CSV data to a pandas data frame. So we use this particular statement, that heart underscore data. This is nothing but the pandas, the name of this data frame, that is heart underscore data. And here we need pandas, that is pandas as pd dot read. We need to read this CSV file. So read underscore CSV, and this is the name of the file, that is heart.csv. So we'll see this hands-on in the afterwards. So this is the file name. So with the help of that, we able to convert the CSV file into the pandas data frame. And if you want to see the first 5 rows of this data frame, so we use this statement heart underscore data dot head. So with the help of this, we can able to see first 5 rows. So see here the output of this heart underscore data dot head. So it will display first 5 rows. That is the index of first row is 0 and the fifth row is 4. So 0 to 4 is 5 rows, and these are nothing but the name of columns. So this is the data frame. So the CSV file is successfully converted into the Pandas data frame. So data frame is nothing but it's kind of tabular structure which have rows and column. So this is this process through which we can able to convert the CSV file into the Pandas data frame. So once the data is converted into Pandas data frame, then we can perform various operation on this data frame. Then if you want to see the last 5 rows of the Pandas data frame, so here we use this statement heart underscore data dot tail function. So tail, so it will give last 5 rows, that is 298 to 302. So this is the statement which is used to see the last 5 rows of the data frame. Then if you want to observe the shape of the data frame or the size of the data frame, means number of rows. That means the data frame will consist how many rows and columns. So we use heart underscore data dot shape. So with the help of this, the output is the data frame will consist 303 row, right from 0 to 302, which is nothing but 303 rows and 14 columns. So here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. So this data frame will consist 14 columns and 303 rows starting from 0 to 302. The first row having the index 0 and last row will having the index 302. That's why we have 303 rows and 14 columns. Then if you want to get some information about the data frame, means the data frame will have any null value or the type of the value, whether it is the integer value, floating point value, or the object value. So we need this info function here. So getting some information about the data. So we use the statement heart underscore data dot info. So with the help of this, we can able to find the useful information. Means this is the name of the column, that is age, sex, CP, TRT, BPS, then cholesterol value, FBS, then rest, tax, G, then Thalax, then old peak. So these are nothing but the name of the column. So we have the 14 columns right from 0 to 13, and the values are not, means none of the column having the null value, and all these values are integer. One value is floating point, but it is 64 bit, and this is the floating point 64 bit, that is one value, and integer 64, that is 13 value. So we have total 14 value right from 0 to 13. And this is the memory uses, means we use this data frame, this uses 33.3 KB memory space. So this is the kind of information about your data frame. So we use, if you want to get the information about data frame, so we need to use this heart underscore data dot info. If you want to get the statistical measures about the data, means if you want to get the statistical measures of the data, means what is the count, mean, standard deviation, mean value, 25% value, 50%, 75%, the maximum value of the data frame. So we use this describe function here. So this describe function will give the statistical information about the data frame. So this information is very much useful. Means we need to find what is the average age of the person which is having the heart disease, or what is the average age of the person which is not having the heart disease, or what is the value, that is cholesterol value, and the another parameter through which we can identify that. So this is the very useful information through which we can able to get the statistical information about the data. So this is very useful function in machine learning. So here with the help of this, we'll get the different kind of the information, that is the statistical information about the data frame. Now if you want to check the distribution of the target value, so here the output is nothing but the target. Once means the person is having heart disease, and 0 is nothing but the person is not having the heart disease. So if you want to give the target information, checking the distribution of target variables, so we need a statement that because this is nothing but the name of the column, so the information is collected the column wise. So heart underscore data output column will be nothing but the it will consist the target value, that is it consists the information in the form of 1 and 0. So we use this function dot value underscore count. So it will give the information, means the person having the heart disease, that is 165 out of 303, the 165% is nothing but it is having the heart disease, and the 138% out of these 303, 138% is not having the, or we can say that not heart patient. So this is the useful information which can be obtained with the help of this step. Then next step is nothing but splitting the features and the target. So we need to split the features and the target. So y is nothing but the target. Y variable is used for holding the target value, that is the output, and x is nothing but holding all the feature, that is right from 0 to 13. So we are using the 14th column as a target, and it is used, the y is used to hold this target value, and x is used to hold all the parameters. So we use this statement x is equals to heart underscore data dot drop. So we need to drop the target, that is output, from this data frame. Heart underscore data is nothing but the name of data frame. So we need to drop this column, that is output, because we use this output as output for y variable. So y variable will hold this output. So we need to drop this column from the x variable. So we use this heart underscore data dot drop. So columns equals to output, this is the name of the column, and axis is equals to 1. So what is the significance of axis is equals to 1? If you want to drop any column, we need to specify axis is equals to 1, and if you want to drop any rows, we need to specify axis is equals to 0. So this is the meaning of that. And here we initialize, or initialize y for holding the output. So we use y is equals to heart underscore data for this output. So here if we print this xy, so see here in this x there is no output. So here in this there is no output, and y will hold this output. So this way we can split the features and the target, means we are separating the features for training the model, and target is nothing but the output. Now next step is nothing but splitting the data into training and testing. So here we need to import this 10 test split already. So we have imported this 10 test split from the Scikit Learn. So we are using this x underscore train, x underscore test, means we are splitting the x variable into train and test, and similarly y variable into train and test, which is equals to train underscore test underscore split, and the variable x y. So y is nothing but it will hold the target value, and x is nothing but it will hold all the features. And test size is equals to 0.2. It means that we are using 80% data for training purpose and 20% data for testing purpose. So that's why the test underscore size is equals to 20%. And startify is equals to y, means we are using that, means the equal amount of that output is y and 0 value, because target is nothing but y will hold the value 1 and 0. So it will split it equally. It means it is not required, it is not like that, means the y will in one group we have the maximum 1, and in one group we have maximum 0. So startify is equals to y, means we are using this target, we are splitting this target equally. And the random state is equals to 2, means if you are using the same algorithm, same code, so in my case the data is split the same way, you can able to split the data. So this is the random state is equals to 2. So you can take any value, but if you want to split the data same as in my case, so you need to specify random underscore state is equals to 2. Then let's see the shape of this x, and x dot shape, x train dot shape, x test dot shape. So here the total value in this x, we have 303 rows and 13 columns. So the output column is before that we have 14 columns. So here there is no output column. That's why the x dot shape is equals to 303 rows and 13 columns, and x train. So 80% of 303 is 242, which is used for training purpose, and the 20% of this 303, which is 61, is used for the testing purpose. So this way we can successfully split the data in training and testing purpose. Then next is model training. So we need to import, already we have imported this logistic regression from Scikit Learn. So here we use this model is equals to logistic regression, and here the training of the model is done. So here we use this model dot fit. So this statement is used to train the model. So we use this model. So we need to specify model is equals to logistic regression. Means logistic regression is we did not need or do not need to specify this logistic regression again and again. So we initialize this logistic regression model as a model, and we use this model for training purpose. So model dot fit is used for the training purpose, and we passes the parameter x underscore train and y underscore train. So this data already we have successfully split it. So this train data is used for training the model. Then next is model evaluation. So here we need to observe the accuracy of the model. So we need to see the accuracy of training data. So with the help of this, we need to pass the statement x underscore 10 underscore prediction. So we need to predict the model with the help of train data. So model dot predict x train, we passes the x train value, and training data accuracy underscore, which is x train prediction comma y underscore train. Then print accuracy on training data. So the accuracy on training data is 85%. So this is pretty good accuracy which is obtained, that is 85.12%. And if we passes the test data, so in case of test data, so simply replace in place of x train, we passes this x underscore test, and this is the x test prediction. So the accuracy is 81.96%. So the model is predicting pretty good. So this is the accuracy of the model. Next, building the predictive model. So once the model is trained and predictive, it will give the good accuracy. So we need to build the predictive system. So here we are just observing in one case. So here in input data, so we are inputting the data. One case means we are passing the value of one rows here, then changing the input to a numpy array. So we need to change this particular value because it is a CSV file. So we need to change this into numpy array, because we are using the particular value. So we reshape it, input data reshape, input data is numpy array that reshape. -1 means we are not using the target value. Then prediction, that's model dot predict input data reshaped and print prediction. And here we use the decision making statement. If prediction is equals to 0, the person does not have the heart disease, else the person have the heart disease. So here in this case, the model is predicting correctly the person does not have the heart disease, because for this particular value the target is 0. So here it will predict correctly. So this is nothing but the building the predictive model. So this is the all about the theoretical presentation of that. So I request all the participants, so please be with me with the laptop and the internet connectivity, so that I can further move with the hands-on. Please give me so for hands-on, you do not need to install, if you don't have any Python installed in your system. So there is no worry for that. We use this hands-on with the help of this Google Colab. So just go to the Google and just type that Google Colab. So here this Google Colab is there. So this is the platform through which we can able to perform the machine learning. We can run the machine learning algorithm. So this is the Google Colab. Go to new notebook. It is visible now. Screen is visible. Hello.
Yes, sir. The screen is visible, but it has been stuck on that PPT only.
Okay. Let me check. Now it is visible.
Yes, sir. Now it is visible.
So this is nothing but the Google Colab. So just go to the Google and you just type Google Colab, and first you connect it. So it is connecting. It is showing that it's connecting. And here you need to rename it. That is ML project. So as already explained, the first step is nothing but if you want to write a text. So here we need to write a text. You just click a text button here. So here you need to specify the text, that is import dependencies, and just press shift plus enter. So here we need to import the libraries, import numpy as np, then import pandas as pd, then from sklearn dot model selection. Font is visible, na? Should I make some sklearn dot model selection, import print test split, and from sklearn dot linear model import logistic regression, and from sklearn dot matrix import accuracy score. Now let's run this. So enter, shift plus enter. So here the first step is that we need to import all the dependency. So this is the first step. Import dependency means we need to import all the libraries, useful library for machine learning, that is import numerical Python as np, import pandas as pd, and we need the train test split because we need to split the data in training and test purpose. And from sklearn model we need logistic regression because I'm using this logistic regression for this hard disease prediction. And from sklearn dot matrix we need to import the accuracy score for predicting the output. Now next step is that converting the CSV file into the pandas data frame. So we first need a CSV file. So for loading the file, so kindly click this folder, and here there is a upload option. So we need to upload here, and in my case I am having the already the hard disk data. So you need hard disk data from your sensor and convert it. So this is the hard disk data, and just load it. So here the data is successfully loaded, that is hard and dot csv, that is the comma separated value. So the second step is that we need to convert this csv file into the pandas data frame. So the second step is that convert csv data into pandas data frame. So here the data frame name is heart underscore data, heart data equals to cd dot read underscore csv, and here we need to mention the name of the file, that is heart dot .csv. So this is the name of file. You can see here the name of the file is heart.csv. So heart.csv. And if you want to check the first 5 rows of this data frame, so use this statement